We are exploring how glaciers move and respond to changes such as climate change. To do that, we're using various technologies. We're studying two different glaciers in Iceland which flow from this large ice cap. Fjalls flows down from a very large mountain, whereas Breda to the east is a much flatter glacier, but they are both quite easy to get to carry out our research. As these glaciers melt, they contribute to sea level rise, and so it's very important to understand the nature of their retreat. As these two glaciers melt, they leave behind large lakes, and these lakes can actually affect the melting of the glaciers. Previously, we measured the speed of the surface of the ice doing what most people do, which is to leave a very accurate GPS recorder on the surface like this. Sadly, you have to leave it for a very long time and then come back to collect all the data in order to calculate where the position was. We're using new generations of small GPS units such as this one. The way it works is this fixed position GPS transmits corrections to the one on the glacier, and then the one on the glacier can calculate exactly where it is. We designed these units, which go on the glacier, to wake up every 3 hours and measure exactly where they were to within, say, a centimetre, and then once per day transmit that data back to the UK using satellite communications. The data we get back from the GPS units is amazing. Here we can see the results for 1 year. At Fjalls there are high speeds during the summer and generally low speeds in the winter, but during the winter there are temperatures when they go over 5 degrees where there is a series of little speed up events. Breda doesn't really show this velocity pattern. The velocities are highest during the summer, but during the winter there are no specific temperature related speed up events. Instead, there are speed up events during the year which appear unrelated to the weather conditions. We used a quadcopter to take hundreds of images of the area so that we could compute a 3D model every year and map all the changes that were happening to the ice. To do this, we need to place very accurate ground control points and then process all the images when we get back. The 3D models we make look like this. They give us the ability to calculate how far the ice has retreated, as well as looking at new landforms which are being revealed.